It's about drive, it's about power. We stay hungry, we devour. Put in the work, put in the hours, and take what's ours. Like in some more in my veins, my culture banging.
Alright, so this is the friction stir extrusion machine instruction documents for the electrical system. So first you want to make sure that the slide potentiometer tab is at the bottom touching the die plate, as we're going to show in the next video. And also you want to make sure that your limit switch is set to where it would be pressed once the material is fully extruded or the tooling is touching the die. And it's already set in this case, so all we're going to be doing is sliding the tab down to where it's touching the die plate. Then you want to plug in your 120 volt plug to power on your PLC and other components. And then you want to make sure that your extension cord is plugged in for your 240 volt system for the VFD. And you want to make sure that the circuit breaker for this is on. Next, you're going to open your NEMA box and flip your PLC breaker into the on position, which is up, and the light should come on the PLC. And then you want to turn your contactor on by pressing the green button. So this is the first screen that will come up whenever the HMI power is on. So you have two modes of control, force control and speed control. Force control is a constant force applied to the workpiece. Speed control is a constant speed that you're extruding at. So to use one or the other, you're only going to select the force control parameter. So you'll click force control, the button will turn green, and then you'll input your desired force. Or if you're using speed control, you'll hit the speed control button, it'll turn green, and then your desired speed. So force, that includes the weight of the die and the plate. So whenever the die or the die platform is raising, it's around 250 pounds. So it's whatever force you want to apply plus the 250 pounds. So say we want to apply 50 pounds to the aluminum workpiece, then we'll put in 300 pounds because it will be the 250 when raising plus the 50 pounds you want to apply to the aluminum. And then speed control is entering a desired speed in millimeters per minute. Ideally, you want to stay around 10 millimeters per minute. In this example, we're going to go to force control. So we're going to hit initialize button for 3 seconds. You need to do this at the beginning of every experiment. You're going to hit the force control button. That's going to stay green. And we're going to apply 32 pounds to the workpiece. That's 250 plus 32 is 282 pounds total. And then you click enter and continue to the next screen by pressing F2. Once you press F2, you have two options to control the heat up time. You have the heat up time control, or you have the heat up temperature control. In time control, you will count down basically. Say if you put in 30 seconds, it'll count down 30 seconds before extrusion actually begins. So it'll heat up for 30 seconds by drilling. This isn't as efficient, so we recommend temperature control. It works the same as the last screen. You press 1, it's going to stay green. And so you only want to click one or the other. You only want to do time control, or you only want to do temperature control. In this case, we're only going to do temperature control. So you click temperature control, it's going to turn green. You enter your desired starting temperature. So this is going to be the temperature that is read by the thermocouple, which will allow the extrusions to actually begin after the heat up phase. And then you're going to enter your desired extrusion depth of your workpiece, which is how far you want to drill into your workpiece, which is going to be detected by the slide potentiometer. So during the heat up phase, the stepper motor is not active. It is just the drilling done by the induction motor. So basically the stepper motor will remain at idle until that parameter is reached. So say if it's time control, it's going to remain idle until it counts down from 30. But like we said, we recommend temperature control. Probably a good starting temperature is around 150 degrees. That's going to soften the aluminum a good bit. But basically it's going to heat up and drill using the VFD or the spindle and the VFD until the temperature is reached. That is your starting temperature that you input on the screen. So in this case, like I said, we're going to do temperature control. We're going to start at 92 degrees. This is just so we can warm up the thermocouple by hand. And we're going to extrude, I believe, 25 millimeters into the material. And then you're going to click F3 to continue to the next screen. So after you hit F3, you actually want to continue and click F4. This will bring you to all your graphing and station monitoring screens. So you can look at the amount of force applied over time, the amount of temperature applied over time, the stepper speed it's revolving at. You can look at its machine state, like if it's extruding or if there's an error, the distance that's been extruded, or the amount of time left in the heat up phase. And you can also look at the spindle speed, which is the speed that it's rotating at or drilling at. And then all data displays multiple of these on one screen to simplify everything. But in this case, we're going to click on spindle speed, and so we can set the drilling of the induction motor at the certain RPMs desired by the user. So before actually pressing F4 to get to the next screen, you need to adjust your panel potentiometer to where it all the way is in the counterclockwise position, so that's its minimum starting point before you continue to the next screen, so that way you can accurately adjust the spindle speed. So you can see that we adjust the potentiometer to its minimum. We're going to click F4, go to spindle speed in the top left corner, and we're going to adjust the panel potentiometer to around a quarter of the way after we flip on the switch. And after the switch is on, the motor begins spinning, and I think we let it go up to around 500 RPMs, and it takes a second to accelerate because of the slow acceleration time to avoid any inrush current on the VFD. And so once it begins to steady state, we can check the spindle and make sure it's actually rotating, and you'll be able to hear it, but in this case you can see it on the screen. So then you can go back to F3 and you can manually raise or manually lower the stepper or the die platform using the stepper motor to put the pre-extrusion in the correct height. And then after you have it at the correct height, you want to hit 0 distance and extrusion active. So what we just did basically is we hit the manual raise button. That's going to raise the die platform to basically contacting the workpiece inside of the aluminum. And once we have the proper amount of force applied, whatever we really want it to be, you can click the 0 distance. You could also use the incremental raise. It's just raises the platform at a much slower rate, so it's only 0.2 millimeters at a time, and it's much more precise tuning. But basically, once you have that amount of force applied that you want for the heat up phase, you're going to click Start Extrusion, and during the heat up phase, the stepper motor is going to wait until those parameters of either your temperature reaching its desired temperature. So in this case, the stepper motor won't begin rotating until it hits 92 degrees. And to increase the temperature, you can raise it by hitting the incremental raise push button, because that's going to increase the force. Once the force increases, the amount of force applied to the workpiece will increase as well. And before you hit the start extrusion button, you need to make sure you hit your 0 distance button. That's going to basically zero your distance and set it as your starting point for your slide potentiometer. So basically, once you hit the start extrusion push button, you enter your heat up phase. During this heat up phase, you can use the manual raise and incremental raise push buttons to increase the amount of force, like I said. And as the force increases, the amount of temperature, the amount of force increases leads to more friction. This leads to a greater temperature inside of the die. And so say you have a very high heat up temperature of around 300 degrees, you can use the incremental raise push button to slowly apply more force without risking any damage to the screw jack. And this will kind of heat up your heat up phase by applying more force to get a higher temperature for your extrusion before it actually begins. And I'd be very wary of using the manual raise during the heat up phase. The manual raise basically works. The stepper motor will only raise as you're holding this button. So if you're holding the push button for 3 seconds, it'll raise for 3 seconds at a set RPM set within the ladder logic. So use the incremental raise during the heat up phase, just so you can very slowly increase the amount of force applied. That way you can generate more friction. This more friction generates more heat, and you'll be able to reach that temperature faster. But I'd recommend using the incremental raise during the heat up phase. So during the heat up phase, you can go to F4 and then go to all data, and you can look at all of the parameters. So in this case, we're going to heat up the thermocouple using our hand. We're going to see it's going to increase up to 92 degrees. And that basically means that the heat up phase has been met and the stepper motor is going to begin rotating. So in this case, you can see it's rotating, and it's going to continue rotating until that force has been met. And you're going to add 4, and you're going to go to stepper speed. You can see it's at 15 millimeters per second, which is its default for the constant's force control. So once it reaches above 282 pounds, so right now we're using the crank wheel to increase the amount of force applied, the speed will drop to 0 because of the PID loop. And once we go lower than 280 pounds, the speed will increase back to 15 millimeters per minute. And during this, you can switch to all different screens. You can look at the amount of force applied. So here you can see how my partner is adjusting the force applied by raising and lowering the die platform with a piece of wood between it to adjust the weight. And you can also see the temperature that we're at. And you can see the state and the amount of distance extruded, as well as what state it's in. So in this case, it says extrusion active. So there are multiple ways to stop the machine. The 2 main ones are this contactor. You hit the red button, that'll turn off the VFD, or you hit the emergency stop button, that will stop everything. Or you can hit that switch, hit it to the off position, that'll turn just the VFD off, or the the drilling, so that'll just stop the drilling motor. To stop the actual operation autonomously, the upper limit switch will be triggered. Lower limit switch shouldn't be triggered because you're going up. Or the extrusion depth will be met by the slide potentiometer, and everything will automatically stop. So in this case, we're going to end the extrusion by manually raising the slide potentiometer tab. It's going to go above our 25 millimeters. So it's going to say extrusion is completed at our state, and the red light's going to go off, and it's going to make a buzzing sound, and then the step motor is going to stop rotating. And to turn the motor off, you flip the switch up. You can also turn off the buzzer if it keeps going off by pressing the turn off light and buzzer button on screen 3. So once extrusion ends, say the upper limit switch is triggered or the slide potentiometer detects a full extrusion by the depth that you set originally, the stepper motor will basically receive a fault and will not operate anymore until you go to screen F3 and hit the access reset button for 3 seconds. So basically, once the access reset button has been pressed, you can use the manual lower to lower the die platform with the stepper motor. Otherwise, if you try to hit it without hitting the access reset button, the stepper motor will not turn. If you lower the machine too much by holding the manual lower, you should be triggering the lower limit switch. That'll stop it in its place, same as the manual raise, and in that case, you'll also need to hit the access reset button and then hit the manual raise to raise it to where you're not triggering either of the limit switches. So you can see here we put the access reset button, and to reset the axis, we hit the manual lower, and now you can see the stepper motor is rotating to lower the die platform. Once extrusion ends and you remove the die, you can hit the red button on the contactor that'll turn off the VFD, open the NEMA box, turn off the PLC breaker, that's going to turn off the PLC, unplug your 240 volt power cord, and then unplug your 120 volt cord that supplies your PLC and everything else. But basically, all this video instruction does is follow this flow chart here. The flow chart has all of these instructions written out in a step-by-step fashion, and it has the different options like force control, speed control, or temperature control, and time control. And it also lists the causes to how things can stop and the certain buttons to press in case of an accident or anything. The biggest thing here is just remember to be safe. The emergency stop button will stop everything in case anything goes wrong. So just be wary of that, and thank you for watching.